Welcome to Herzing University Online. This course is titled Color Theory in Design. The course number is GA201. The following presentation will cover Week 1 and is titled Introduction to Color. Introduction. An understanding of color is a fundamental skill that all designers must possess. Though we all become familiar with colors at an early age, being skillful at manipulating color demands a more thorough approach. In the hands of skilled designers, color can be a powerful and indeed influential communicative device. When used properly, color can direct the way a viewer interprets the design and can affect the mood, tone, and overall effectiveness of the message. In this section, we will begin with a general introduction to the more common terms used to describe color and some basic classifications of color models. Part 1. What is color? To understand how to use and manipulate color, one must first understand how the human eye perceives color. Color is in fact wavelengths of light that are visible to the human eye. Each wave consists of a different length. Red is the longest and violet is the shortest. In terms of light, mixing all of these wavelengths creates white, whereas the absence of light creates black. All color is derived from light, either natural or artificial. The amount of color perceived is directly linked to the amount of light present. The more light available, the more color will be visible. Color is perceived through the human eye through color receptor cells, or cones. These cones absorb red, green, or blue waves and translate them into color. The color visible to the human eye is called the visible spectrum. On average, humans can detect approximately 10 million colors. This is known as the human color space. To understand how color is perceived, we must understand the physics of light. These properties cause and affect our ideas of primary color. The two types of primary color spaces are additive and subtractive. The RGB colors, red, green, and blue, are the primary colors of pure light and are referred to as the additive primary colors. The subtractive primary colors, made from reflected light, fall into two categories: CMYK, cyan, magenta, yellow, and black, and RYB, red, yellow, and blue. RYB colors are referred to as the artist primaries and are the basis for most color theory. All three color spaces come into play when designing. Designers choose colors based on the RYB space, generate layouts on the computer in RGB, which, when printed commercially, are converted into CMYK process lithography. The following images describe the functional differences between these models. The RGB model as it applies to a projected light. The visible light channels of red, green, and blue represent the greatest possible brightness or intensity. When they overlap, other colors are produced. Red and blue light produces magenta. Red and green light produces yellow. Blue and green light produces cyan. When red, green, and blue light are added together, they produce white light, hence the term additive. Mixtures of these primary colors make up a large part of the human color experience. Televisions, computer monitors, and scanners all operate on RGB color mixtures. The CMYK model as it applies to reflected light on opaque surfaces. The subtractive color space of CMYK operates on the principle that all surfaces absorb some color waves while reflecting others. This is particularly true of white surfaces like paper or canvas. The sensation of color is produced when a surface absorbs all wavelengths except those the eye perceives. When color is experienced through reflected light, it is called subtractive. The cyan, magenta, yellow, and black ink that commercial printers use is fairly transparent, which allows for the hues of each to show through, producing new tones. Cyan overlapping magenta produces blue. Magenta overlapping yellow produces red. Cyan overlapping yellow produces green. Combining cyan, magenta, and yellow produces a color close to black, though true black ink, K, which stands for key color, is often printed to compensate for the thin nature of the transparent ink. All printed material from textbooks to magazines to Sunday newspapers use the CMYK subtractive color model. The RYB model, as it applies to reflected light on opaque surfaces. The RYB, or artist primaries, are the most familiar of the color models. Most color theory is based on the combinations of this subtractive model. When using opaque pigments, such as paint, the resulting reflected colors create common secondary mixes. Red and blue combine to make purple. Red and yellow combine to produce orange. And yellow and blue create green. We will focus on this primary model in the next section. Part 2, the properties of color. Whether using additive or subtractive primaries, each color must be described in terms of its physical properties. These properties work independently of each other, but must each be addressed to fully describe a color. The scientific description of color is known as colorimetry. In a subjective application of colorimetry, a color is described in terms of hue, saturation, and brightness. A more objective colorimetric system measures the dominant wavelength, purity, and luminance of a color. Hue is the common name of a color and indicates its relative position on the visible spectrum. Hue is determined by the particular wavelength of the color in a ray of light. Saturation refers to the intensity or strength of a color. A very vivid color has a high or full saturation without any black, white, or gray in it. Saturation describes the richness of a color. Brightness, sometimes called value, is the relative lightness or darkness of a color, or its reflective quality or brilliance. A color's brightness can be manipulated by the addition of black or white. Adding white to a color makes it lighter. A color that has white added to it is called a tint. Conversely, a color can be made darker by adding black. This is called a shade. Summary. Color is wavelengths of light that is visible to the human eye. The more light available, the more color can be perceived. Color visible to the human eye is called the visible spectrum. The two types of primary color spaces are additive and subtractive. Color perceived as projected light is considered additive color. Color perceived as reflected light is considered subtractive color. The The primary additive color space is the RGB color model. The two most common subtractive color spaces are the CMYK and RYB color models. Colorimetry is the study of the properties of color. The most measurable properties of color are hue, saturation, and brightness. End of week 1.